Good morning to all of you. Let's begin our session on cryptography, network security and cyber law. Today it is a continuation of module 3, wherein it is the 7th session on key management, authentication, IP security and security at transport layer. Now in this session we will be discussing about authentication using Kerberos, and also we will see what is meant by biometric authentication and what are the various preliminaries involved in it and various um, features that contribute to the biometric authentication. Now before we get on, let us see what are the objectives of today's session. Now after attending this session you shall be able to describe Kerberos authentication protocol, and also you will be able to explain biometrics and error measures. Now let's try to understand what is meant by a password based system and what are the features required by a password based system. Now this password based system, let's take a simple scenario over here wherein we'll consider this entire scenario to be occurring in VTU campus. Let's say there are multiple users in VTU campus and there are multiple servers catering to the requests of these users in the campus. Now let's consider this scenario. We have considered just one user over here out of multiple users, and few of the servers are depicted here. This user, once logged in, may wish to access multiple resources present on various servers. Now over here there are 3 servers which the user is wishing to access, but he has just logged in once. Now what is the possibility of a person to access these particular servers with by just logging in once? Now one possibility is for the user to have multiple passwords. So the user 1 can use a password for accessing, let's say password P1 for accessing email server, and P2 for accessing the web server, and P3 for accessing the file server. Now as a user we do not have the tendency of remembering multiple passwords. If there are 10 servers or 20 servers existing within this particular organization, in that case having a separate password for each of these servers is really cumbersome, and remembering them is even more difficult. Now there should be some way out in which the user is able to ease his life. Now what is the other possibility? Now the other possibility in case of password based system is that the user uses one password in order to access various other servers present in the organization. Now what is the difficulty here? User is just using one password to access every other server. Users life is made easy, but what is the difficulty at the other end wherein there are multiple servers? All these servers need to maintain a file which will contain the passwords of the user, and this file has to be shared across all the servers need to have this particular password file. Maintaining and distributing such a file which contains password of various users is difficult at the other end. Now let's see further what are the needs of a password based system. Now whenever we provide password to our system, this password should not be transmitted in clear. Now what happens if a password is transmitted in clear? An attacker could gain access if passwords are transmitted in clear. So we avoid it. Now what is the second requirement for a password based system? It should not be possible to launch dictionary attacks. Now the attacker should not be able to eavesdrop on the passwords that are shared with the other end, and he should not be able to store those or guess those and launch a dictionary attack. Now, the third requirement for a password based system is that whenever we are storing a password on an authentication server, these passwords should not be stored in clear. That means they should be transformed into something else, encrypted and then stored, so that we are able to avoid the dictionary attacks. Now, the fourth requirement is the user, it should not be possible to launch dictionary attacks by obtaining the file containing cryptographically transformed versions of the password. Now, even if the attacker is able to get the access to this cryptographically transformed passwords file, even in that case, he should not be able to launch a dictionary attack. Now, over here, the fifth requirement of a password based system is that the user enter his passwords only once during the login, and then he can have access to the resources until he logs out. He need not re-enter the password again and again when using different resources or multiple resources. Now let us take an example of Outlook. Outlook provides access to email, access to drives. It also allows creation of online documents, online forms, online Excel sheets. Now, when we shift from an email to, say, like we are storing something on a drive, now when trying to use this particular drive, we do not log in again into the system, right? Now, even if we want to compose a file, a Word file, online using Outlook, even in that case we do not log in again. Once logged in, we are allowed to we are allowed to access entire set of resources that are available under that particular application. Now, this is the requirement of a password based system. Now, let's look at the sixth requirement. The password entered by the user during the login time, it should reside in the machine for very less duration of time. It should not be stored on the system, and it should not stay on the system for a longer duration of time, because there could be an attacker who may compromise the system and get the password. Hence, the password should reside on this particular machine for a very less duration of time. Now, having understood the various requirements of a password based system and how a password based system should work, what are the possibilities associated with this password based system, let us see if Kerberos is able to cater to this particular need. Now, Kerberos is an authentication protocol which was developed at MIT, and it has various versions which were proposed. The latest version is the Kerberos version 5. Now, where is this Kerberos used? The Kerberos is used in Windows operating system, including Vista and also Microsoft Server 2008. Now, this Kerberos protocol obviously derives certain features from Needham-Schroeder protocol, which we discussed in the previous session. Now, what are those ingredients of the Needham-Schroeder protocol that Kerberos has adopted? First is, Kerberos also makes use of a key distribution center referred to as KDC. Now, this is also called as trusted third party, and this is used to provide authentication between two communicating parties. Now, this algorithm of the Needham-Schroeder protocol is split into two logical entities. Now, one of the entity is called as authentication server, referred to as AH, and the other entity is called as the ticket granting server, referred to as the ticket granting TGS. Now, look at the third point. Now, similar to that of the Needham-Schroeder protocol, the ticket is used in case of Kerberos also. Now, why do we use the ticket? Ticket is a safe mechanism to distribute a session key among two communicating parties. Now, what are the other things that Kerberos uses? Now, user A, let's say there are two users who are wishing to authenticate to each other. What does user A do? User A shares a secret key with the authentication server, and this secret key is called as KA. KA is the key that is shared between the authentication server and the user A. And how do we obtain this particular KA? KA is obtained by hashing the user A's password. Similarly, user B shares a secret key with the ticket granting server, and this key is called as KB. Now, if you remember the Needham-Schroeder protocol, which makes use of nonces. Over here in the Kerberos, it uses nonces along with the timestamp. Now, what is the purpose of using a nonce and a timestamp? The nonce and the timestamp help avoid a replay attack. Now, let's start with the actual Kerberos with this particular background. The key distribution center authenticating a user will record the login time and also the maximum duration for which the particular session will run and the session key. The logged in users request for the service. Now, what are the service that the logged in user requests? The KDC creates the tickets for the user and the requested server. Now, the ticket contains the encrypted session key and also other information like the lifetime of the session key, that is the duration for which the session key will be usable or valid. The session key is then further used to encrypt the subsequent messages that are communicated between the user and the requested server. Now, over here we can see that key distribution center is used for authenticating the server. And now, how does the user get authenticated itself to the server? Key distribution center keeps track of all these details, and also the users, once they are logged in, they can request for a service. Now, this is the way the services can be requested. We will get into the depth of it. Now, over here we have a sequence of messages that are exchanged between the client, the Kerberos server, and also the requested server. Now, remember that the client is interested to take services from this particular server S. But before it seeks services from the server S, it has to authenticate itself with that of the authentication server and seek ticket from the ticket granting server in order to access the required server. Now, as we are aware that authentication server and the ticket granting server both together form the Kerberos server or the Kerberos authentication server. Now, remember there are almost 4 entities that are involved over here, client being on one side and the 3 servers being on the other side. Now, there are 3 steps that are involved. Now, client first communicates with the authentication server, and then client communicates with the ticket granting server, and further after authentication the client starts communicating with the server for mutual authentication. Now, the number of messages exchanged by the client with that of the authentication server is 2, and also with the ticket granting server is 2 and the requested server is 2. So, totally 6 messages are exchanged in 3 steps of communication. Now, let us have a look at this diagram. Over here we can see that the user logs on to a workstation and requests for a service on host. Now, this is the user who wants to communicate with this particular server. Now, in order to communicate with this server, the user has to authenticate itself and prove its genuinity with the Kerberos authentication protocol. Now, over here we can see that the Kerberos authentication protocol is having logically 2 entities. One is the authentication server and the other one is the ticket granting server. Now, let us see the user once he logs in and requests for a service on the host. Now, this request is transmitted to the Kerberos. Now, over here we have seen that the user requests for a ticket granting ticket, that is, it requests for a ticket granting ticket from the TGS. Now, the authentication server verifies the user's access rights in the database, creates a ticket granting ticket and also a session key, and results are encrypted using the key that is derived from the user's password. Okay. Now, what is happening here? A ticket granting ticket is generated if this user is found to be valid, and then along with that a session key is generated. Now, these the ticket granting ticket and the session key both are encrypted using the user's password, using the key derived from the user's password. Now, this is a key that is shared between the user and the authentication server. Now, the user is able to receive the ticket along with the session key. Obviously, this is returned in an encrypted form as already discussed. Once it reaches the user, what does the user do? Now, the workstation prompts the user for password and uses the password to decrypt the incoming message. Now, this message which is received will be decrypted and then sends the ticket and authenticator that contains username, network address and the time to TGS. Now, all these details are sent to the ticket granting ticket requesting for a service granting ticket. Now, service granting ticket is a ticket which will allow the host or the user to communicate with the server. Now, what does the ticket granting server do on a request from the user for a service granting ticket? Now, the TGS decrypts the ticket and authenticator which it received in message number 3, verifies the request and then creates a ticket for the requested server if the request is valid, and then sends this ticket along with the session key to the user at the other end. Now, what does the user do? The workstation sends the ticket and authenticator to the server. So, it will ask the server to provide it with a service. Now, the server receives this particular service request from the user which is coming in the message number 5. The server verifies the ticket and the authenticator match, and if they match, it grants the access to the service. If mutual authentication is required, server returns the authenticator. So, if the server has to authenticate itself to the user, in that case, what does the server do? The server returns the authenticator to the user. The user can use that and verify the genuinity of the server. Now, over here we can see that the communication that occurs between the user and the authentication server, it occurs just once per user login session. Okay. Once the user is having access to this system, he need not again and again authenticate himself to the authentication server. Now, over here the communication between the user and the ticket granting server is of this type, wherein this communication occurs once per type of service. What does this mean? Now, once the system is authenticated, let us say this is a Outlook or a Gmail server, to which, let us take a Gmail server example. It is authenticated to Gmail. Now, if I want to access something else within that particular Gmail, like I may have to provide, let us say I want to change the password, I need to authenticate myself just once again. If I have to use some other service, even in that case, I authenticate once again. Now, over here, the user is logged in once to the system, and then for another login, in order to request for a service which is provided by the ticket granting server, what does it do? The user tries to request for a service granting ticket from the ticket granting server. Now, one request for this particular server, if there is another server, another request, another third server, another request, and every time a new server pops up or a different server, if the user wants to communicate, he has to only communicate with the ticket granting server, and no communication is required with the authentication server, since it is already logged in successfully. Now, over here we can see that the user and the server will be exchanging these messages once per service session. I want a service, at that time I authenticate myself to this server with the help of the ticket granting server, and then once I am done with this, I just log out of this particular service or the server and move on to the next server. So, remember, when user communicates with the authentication server, it's one per login session, and with the ticket granting server, it's once per type of service, and with the server, it is once per service session. Now, let's have a look at the various keys used in Kerberos. Now, KC is the long term key of the client. Now, this key is derived from the user's password, and it is known only to the client and the key distribution center. Particularly over here, it is authentication server. KTGS is the long term key of TGS. It is known to KDC and the ticket granting service. Now, KS is the long term key of the network service S or the server S. It is known to the server and the ticket granting service or the server, separate key for each service. And KCTGS is a short term key between the client and the ticket granting server, which is created by the KDC, known only to the client and the TGS. Now, we have KCS is a short term key which is used between the client and the server. It is created by TGS and it is known only to the client and the server. Now, these are the various symmetric keys that will be used in Kerberos. Now, let us have a look at this particular diagram. We have again a simplified version of the previous diagram. We have client, we have the Kerberos authentication server, and we have the server with which the client intends to communicate. Now, within the Kerberos server, we can see that there are two servers involved. One is the authentication server and the other one is the ticket granting server. Now, the first two messages, that is M1 and M2, are exchanged between the client and the authentication server. Now, over here in case of M1, C requests for a ticket granting ticket, and M2, C receives the ticket granting ticket, that is, it can access the ticket granting server. Now, in case of M3 and M4, these are the two messages exchanged between the client and the ticket granting ticket. Now, what happens in case of M3 is C requests for a service granting ticket from TGS. Now, this service granting ticket is a ticket that client needs to access the server. Now, in M4, the ticket granting server sends the ticket granting ticket along with the session key to the client. Now, let us have a look at the last two messages that are exchanged between the client and the actual server with which the client intends to communicate, which is depicted with M5 and M6. In case of the message M5, C authenticates itself to the server, and in case of M6, which is coming from the server to the client, the server authenticates itself to the client. Now, let us see what are the various ingredients of these messages. Now, over here we can see that the client is sending a message to the authentication server. I have divided all the messages according to their communication. The first two messages are intended to the authentication server, next two to the ticket granting server, and the third one is to the actual server or the requested server. Now, over here the authentication service exchange in order to obtain a ticket granting ticket access from TGS. Now, over here client is sending a message to authentication server. Now, what does this message contain? It contains the identity of the client, the identity of the ticket granting server, the time, and also the nonce R1 which is generated by the client C. Upon receiving this particular message, the authentication server has to provide a response to the client. Now, in the second message, authentication server is sending a response to the client, and this response contains the ID of the client for which this response is intended to, and the ticket to access the TGS, and also the session key KCTGS, and the ID of TGS, the times, and the nonce R1. Now, all of this is encrypted using EC. EC is the key, EC encrypted using KC. KC is the key that is shared between the client and the authentication server, and this key is derived from client's password Alright. Now, where over here let us see what we mean by ticket TGS. Okay. Over here we can see it is a session key, the ID of the client, the times which are provided, or the timestamp which is provided, along with that the ID of TGS. All of these are encrypted using the KTGS. Now, we know that KTGS is a key. You can just have a look over here. KTGS is a key that is shared between the authentication server and the ticket granting server. Now, moving further, once client has obtained the ticket, it can now communicate with the ticket granting server. Now, these two messages 3 and 4, we refer to them as ticket granting service exchange in order to obtain the service granting ticket. Now, the client sends a message to the ticket granting server wherein it specifies the server's ID with which it wants to communicate and the times or the duration of the session, the ticket TGS, the authenticator C, and also a new nonce is generated R2, where authenticator C includes the ID of the client and the timestamp 1. Now, both of these parameters are encrypted using the key which is shared between the client and the TGS. Now, the ticket granting server, in response to the message 3, generates a ticket to access the server S, and also it provides a session key KCV. Now, let us look at this particular message. Now, ID of the client is included, the ticket to the server is included, and also we have the ID of the server, the session key which will be exchanged or which will be used by the client and the server, the time or the duration of the session, and also R2 is the nonce. All of this is encrypted using the key KCTGS. Now, KCTGS is a key that is shared between the client and the ticket granting server. Now, what does this ticket S contain? Now, this ticket S contains the ID of the client, the session key which is exchanged between the client and the server, and the times also. All of this is encrypted using this session key, that is it is encrypted using the key that is shared with that of the server. ES is a key, or KS is a key that is shared between the server and the ticket granting server. Now, once the client has obtained a ticket to access the server and also a session key to communicate with that of the server, this should be KCS, S instead of V. Now, once the client has obtained these two, it can further communicate with the server and obtain the service. Now, first client sends a message to S. It will send the ticket to the server, and also it will send the authenticator. Now, the authenticator contains the client's details, along with that it contains the timestamp 2, both of which are encrypted using the key that is shared between the client and the server S. Now, the server in response will send its details for further authentication by the client, and this message contains the timestamp 2, which is incremented by 1. This timestamp 2 was received from the client in the previous message, that is message number 5. Now, this timestamp is encrypted using the key that is shared between the client and the server. Now, over here remember, the first two messages are used or exchanged between the client and the authentication server, and the client performs this operation only once for the entire login session. Now, if it wants to access a server 1, the client communicates with the ticket granting server to give it a ticket in order to access to the server 1. Now, for every server that the client wants to communicate, it has to request the ticket granting server for the ticket to communicate with that particular server. Now, this is the number of this communication between the client and the ticket granting server depends upon the number of services the client wishes to access. The third communication which contains message 5 and 6 is usually used between the client and the server to mutually authenticate with each other before obtaining a service from the server. Now, this is exactly what happens in a Kerberos protocol. Now, the short term key, session key over here are the session keys, and the long term secrets are used only to derive these short term secrets or these short term keys. Separate session key is used for every client and server pair, but multiple user server sessions reuse the same key. Now, the proofs of identity over here, be it of the client or the server or the ticket granting server, is provided with the help of authenticators. Client encrypts his birthday, address, current time using a short term session key, which will help prevent the replay attack. The server learns this key separately and verifies user's identity. Now, over here we can see that there is lot of symmetric key cryptography that is involved, because lot of keys are shared secrets. Now, what are the practical uses of Kerberos? Kerberos is used in email application, FTP, network file systems, and many other applications which have to be Kerberized. Use of Kerberos is transparent to the end user. They are not aware that there is a Kerberos protocol running underneath. Transparency is important for usability. Now, local authentication also makes use of Kerberos, wherein we log in and sue in case of OpenBSD. Authentication can also be provided by Kerberos for network protocols, which includes rlogin, rshell, and telnet. Now, let's move to the second half of this particular session, that is use of biometrics in order to authenticate a person or a user. A biometric is a biological feature or a characteristic of a person which will uniquely identify him over a lifetime. The common features that include for biometric identification are the face recognition that we are using latest in our latest telephones or the mobile handsets, and the voice recognition, manual signatures, and fingerprints. And even the patterns of your iris and the DNA can be used for biometric authentication as biometrics for authentication. Now, recent addition to this biometrics includes keystroke dynamics and also the trait of a person's walk. The way in which a person walks is also suggested to be a biometric identification. Now, generally, how do we recognize that so and so is a person? Now, like we see the traits of that particular person in order to recognize it is X, right? Now, biometric forms were first proposed as an alternative or a complement to password. Now, passwords are based on what a user knows, whereas biometrics are based on what a person has. Now, biometric links the identity of a person to his physiological or behavioral characteristics. There are two main processes that are involved in a biometric system. Now, we all use biometric system in order to log in ourselves to our university or wherever. Now, what does those? First, you need to enroll over there, and every day the system keeps on recognizing you. Now, what do we mean by this enrollment? In this phase, the subject's biometric sample is acquired. Let me say we have a biometric in our organization, and before we start using this particular system, we have to enroll ourselves. Now, let's say it takes our fingerprint, thumbprints. Now, I need to give samples even before I start using it. Now, I may give some 5 samples or 3 samples so that the system is able to recognize even if I give in a different angle. So, over here biometric subject's biometric sample is acquired, that process is over, and then the essential features of the sample are extracted to create a reference template. Now, with my particular name, a template is created and stored in the database, so that they are used for further matching when I try to log in every day. Now, sometimes multiple samples are taken and multiple templates are stored to increase the accuracy of the match in subsequent recognition phase. Now, biometric recognition system. Now, the fresh biometric sample of a person is taken and then it is compared to the reference templates to determine the extent of the match. If there is a match, then you are allowed to access the system. If there is no match, you may be asked for re-entering your thumbprint or whatever biometric with which you have logged in. Now, biometrics are used in two different scenarios. One is for authentication of a user to the system, or it is used for identification of an user to a system. Now, authentication refers to biometric system stores the login name and the biometric sample. It is a one-on-one match or one-to-one match, whereas identification is wherein a biometric sample of the subject is taken, but the subject's identity is not presumed to be known beforehand. It is assumed that a database of biometric samples of several users already exists and you are trying to identify from that particular database. Now, in identification, the subject's biometric sample is compared with the samples in the database to determine if the match exists with any one of them. Identification involves one-to-many match over here. In case of authentication, it is one-to-one match. A typical application of authentication is in access control, while identification finds widespread use in forensic and criminology. Now, what are the characteristics of a good biometric system? One is universality, second is uniqueness, and third one is permanence. Let's see what we mean by universality. Universality is wherein all human beings should be able to contribute a sample of the biometric. For example, the speech impaired may not be able to contribute towards voice recognition system. What is uniqueness? Now, biological samples taken from two different humans should be sufficiently different that they can be distinguished by machine intelligence. One litmus test of uniqueness is whether the biometric samples of two identical twins serves to unambiguously identify them. Now, it is very difficult when we try to identify identical twins or when we try to authenticate identical twins. Now, there should be some way out in order to differentiate them. Now, what do we mean by permanence? Permanence is that the biometric which we have provided as a sample should not change over time. The samples that are acquired during the enrollment may be several years old. Even after 10-20 years, those samples should be still valid. Now, it should be possible to detect a match between the newly acquired sample and that stored in a database of samples of thousands of individuals. For example, a person's voice may temporarily change due to cold. Now, another biometric that is most commonly used is the fingerprint. Fingerprint is an expression left by the ridges and the valleys of a human finger. Each individual fingerprint exhibits distinctive patterns. During the enrollment and the recognition phase, an image of the fingertip is taken by placing it on a plain surface of the scanner. We are all aware of this because this fingerprint is used nowadays in logging into your mobile system. During the recognition phase, the input template must match with the patterns stored already in the database. Now, the simplest approach involves identification of distinctive patterns formed by the ridges. These are called as singularities. Now, what are the other things that are present in the fingerprint? There is an arc, there is a loop, there is a whorl. Now, what does arc refer to? Arc is the ridge that starts from the side, one side of the finger and forms an arc and ends on the other side. Now, when you observe your fingertip, you can see these arcs and the loops and the whorls. Now, what is the loop? The loop is a ridge that starts and ends at the same side of the finger. And whorls appear to be closed cycles or spirals on the fingerprints. Now, all these parameters or all these arcs, loops, ridges and whorls contribute to the uniqueness of the fingerprint. Now, another important biometric that is used frequently is the iris scan. When we log into our laptop, usually we have seen that there is a biometric authentication that occurs with the system. The user has to provide his eyes, his picture of the eye, or he has to the webcam will capture his eyes in order to authenticate him to the system. Now, what does this contain? Iris contain. The iris is a thin opaque diaphragm of smooth muscle situated in front of the lens of the human eye. Its annular shape surrounds the pupil. The intricate patterns of the iris appears to be unique. Two identical twins have iris patterns that are different as those of two unrelated individuals. Now remember, we always wanted to differentiate the twins who have almost all patterns to be similar, identical twins who have all patterns to be similar. Now, iris authentication is one good way of differentiating them. Now, the patterns of an iris are also stable with age. They do not change with age. Now, this marks the end of the session wherein we have discussed about Kerberos. First, we started our discussion with password-based system. What is a password-based system and what are the features required for a password-based system? Then moving further, we have discussed about Kerberos, the various steps involved in authenticating a client to a server, and the number of messages that are exchanged, and how many times a user has to log in, and all that we have discussed in case of Kerberos, and how it is able to cater to the requirements of password-based systems also we have seen. Then we have moved on with our discussion on biometrics and the various biometric parameters and physiological parameters that contribute to the biometric authentication. Now, let's conclude this session with these ideas of Kerberos and biometric authentication, and also if you have any queries, you can revert back on this email or over this contact number. Thank you. Have a great day.